control algorithm, let's focus on the following simple and basic problem. We have a drone, we want to maintain its height with respect to the ground. I have my goal, which is being 1 meter above the ground. More formally, I have my desired height with respect to a given sensor that works, say, 10 times a second. I want to be able to maintain a certain level, say 1 meter. Now I have my current reading. Instead of 1 meter, just for example, let's think of it as being just a little bit less than that, 80 centimeters. I have my error, which is the difference between the desired height, or the parameter which I'm desired to get it, and the actual reading from the sensor. In this case, I have an extra 20 centimeters to go up. My P, my proportional value, going to be 20 centimeters. And if I'm above 1 meter, it's going to be negative. I want to go downward. So if I'm, say, 1.5 meter above the ground, my P will be negative ½ meter. I can think that a basic controller would basically take the P, the difference between my desired value and the actual reading from the sensor, and try to blend it into an algorithm. The larger the P is, the more severe, the more acute the actual maneuver going to be. If I need to define my angle just a little bit, I might do it in a very, very tiny little fixes. But if I see a pedestrian crossing the road and I need to, brake rapidly, or I just want to, there's a car bumping into the intersection, I might want to do a rapid maneuver. So the P, in a way, encapsulate the difference between the desired value and the actual reading value. And in our example, it's all about the height. The problem of using just a proportional, just the P, is that as long as I'm below my desired height, I will go upwards. So eventually, I will go above my desired height, and then I'll go below that. So I'll get this sinus kind of movement or oscillation. And I would not necessarily converge into the right height. So think of a car that moves that way all the time. This is tedious, annoying, might be kind of dangerous. So in a way, we want our control algorithm to rapidly converge to our desired value. For that, we're going to introduce the PID control algorithm, which is the most commonly used, widely implemented, very simple to program kind of algorithm. And we're going to implement it on separately on the height, maybe on the distance, and maybe on other examples. But for simplicity, we'll start with the height.